we're talking 2.1, solving equations and inequalities, and specifically we're looking at how do we solve linear equations and linear inequalities. Later on in the year we'll talk about solving different types of equations, whether they be quadratic, cubic, some of those parent functions we talked about. We'll talk about how to solve them, but here, this is basic. This is just linear. This is stuff you've kind of already done in Algebra 1. So the how do we solve should be a little bit review. How do we represent the solution sets? Probably also review, but we're going to look at how do we graph the set of answers for the inequality. Okay? Now, when I talk about solving equations, I like to call it the block method. And the reason is, let me get this so I have the whole thing. Why don't I have the whole thing showing up? There we go. The reason is because it's kind of the building block. Like if you think about it, how many equations did you end up solving in Algebra 1? And then how many equations did you end up solving in geometry? Okay? This method works for every linear equation. And actually it kind of works for quadratics. There's some pieces of it that we're still going to use. Okay? So it's kind of the building block. It's the base of what we do for algebra. First, you're going to use the distributive property. You have to get those parentheses out of there. They cannot be there. You can't solve when you have parentheses. So we use the distributive property. Just a quick reminder, there's an example up there. A times, then in parentheses, x plus b equals ax plus ab. You're using multiplication to remove the parentheses. The parentheses dropped out on the right side of the equal sign, and that's what we're trying to do when we use the distributive property. Okay? Once you've done it, you might have some like terms to collect. You may not always, but if you do, you need to put all of your like terms together. Now, like terms can only live on one side of the equal sign. Okay, so you're going to look on the left side. Do you have any like terms? Great, put them together. Look on the right side. Do you have any like terms? Great, put them together. You cannot mix terms from the left side and the right side. When it comes to collecting like terms, take each side of the equation one at a time. Remember, like term is anything that has the same variables raised to the same exponent. So when we're thinking about this, just a quick refresher, 6x, 7x, totally like terms. 6x squared, 7x to the third, totally not like terms. Okay? 6 and 7, once again, those aren't like terms. So you can put your numbers together and treat them like terms. Then you're moving all your variables to one side of the equation. A variable is a letter used to represent an unknown number. Okay? We've used x as probably our most common variable, but we've studied what other variables work and what other variables don't work. Remember, we can't use the letter O, we can't use the letter I, we can't use the letter E, because they're pretty much taken in math already. So you'll see a lot of X, W, Y, Z, A, B, C, good letters like that. You got to get them all on one side of the equation. Get them all on one side because then you can start to work with them and manipulate them. In doing that, you want all the variables on one side, and you want then to add or subtract the constant term and get that on the other side away from the variable. So you're going to use addition or subtraction. It's all about doing the opposite. The constant term is a number without the variable. So like plus 7, minus 13, plus 6, plus 8, minus 5. Those numbers in like 7x minus 5. Well, minus 5 is the constant. And since it's minus, you are going to add to eliminate it. You want to cancel that constant term. You're kind of clearing the clutter. You move those parentheses. You get rid of those. You collect like terms. You're simplifying and slimming it down even more. All the variables on one side, great. You're grouping all of those together. Clearing the constant term out, great. Move it away from the variable. We want the variable by itself. Very last thing you're going to do is you're going to multiply or divide to eliminate the coefficient. Okay, so it's the number in front of the variable. You want to multiply or divide to get rid of that. You don't want it there. We want to know just what x equals. Okay, we don't care what 5x equals. That doesn't help us. Get rid of the coefficient so that we can actually know what it equals. Okay? When you do this process, you're going to have some interesting solution sets off of that. They are called the identity set, or the identity solution, and the contradiction. So you have identities and you have contradictions. The identity. The identity is when you get to the bottom of an equation and it looks something like this. 4 equals 4. X equals x. Negative 7 equals negative 7. You have the same number or same variable, same number, same variable, identical on both sides of the equal sign. Your result is always true. 4 always equals 4. -7 always equals -7. So what that means is, when it's always true, is that any real number will work in our solution. The real number means, or real numbers means that any number you pick will make your equation true. Usually we're used to seeing that x equals 5. 5 is the only number you can plug into your equation that works. Well, here when you have an identity, every single possible real number will work. Okay? Oops. All real numbers. Any real number will work in that solution. Okay? That's what we're saying there. The opposite, kind of, is a contradiction. In that case, you might get 4 equals 6, or -7 equals -9. Okay? Those are never true. 4 is not equal to 6. That doesn't even make sense. Okay? What that means is your result is always false. If I told you in class and said, guess what, today 4 equals 6, you guys would think I was an idiot. You would think I was not very smart. And so you have to kind of take that idea and say, okay, 4 can never equal 6. What am I really wanting to say here? Well, in this case, I'm really wanting to say that actually my solution is always false. 4 can't be -6. 4 is not equal to 6. That never can happen. And so there is no number, there's nothing I can do where I would have 4 equaling 6. We use the phrase the empty set. That symbol signifies the empty set. It means that no number that you choose will ever work in your equation. We'll kind of look at that a little bit more. These are kind of tough ideas. It's easy to solve. Boom, x equals 2. Done, Miss Sisto, I got this. Well, now you solve, instead of x equals 2, you get 2 equals 2. You go, duh, Miss Sisto, I know that 2 equals 2. Well, yeah, duh, but what does that mean for us mathematically? Or 3 equals 2. Well, what does that mean for us mathematically? It's not enough to just say, well, I'm right, I'm wrong. No, you have to interpret that 2 equals 2. You have to interpret that 3 equals 2 and think about it in terms of math. And that's what we'll talk about. Okay? The other times you'll get a solution set is when you're working with inequalities. Okay? Inequalities will have an entire set of numbers as their answer. Solving inequalities is totally the same as solving a regular equation with an equal sign. You're still going to use the block method. And you're still going to go through those 5 steps. However, when you get to that last one where it says multiply or divide to cancel, you need to know, and hopefully you already know this, but you need to know that if you multiply or divide by a negative number, if that happens, if you multiply or divide by a negative number, you need to reverse the symbol, the inequality symbol. So instead of being less than, now it's going to be greater than. The equal to part will stay. So let's take a quick look at an example here. Okay? Let's take a look at -4x is greater than -20. Okay? When we're looking at this, we know that, okay, we're right here. We're ready to divide. Great, we're going to divide both sides by -4, get rid of the coefficient. -4 is the coefficient, we want that gone. Okay, so here we go. We get out our fancy calculators, which for most of you, you should be doing this in your head. But you might write that down. You may go, yeah, I got this, I got this, I got this. No, you don't. Okay, fix it. Look at this right here. Once we divide by -4, we need to change the direction that our symbol is pointing. Okay. We need to take it from greater than, the way it is now, and flip it to being less than. Because we divided by -4. That dividing by a negative kind of freaks everything out. We have to flip the symbol. Now this x is less than 5. There are a ton of numbers that are less than 5. There are infinitely many numbers that are less than 5. So what we do is we graph our solution. The answer here is a set. So we're going to graph that set of numbers and kind of represent it graphically. Here's how we do it. The first thing we do, we need a number line. Okay, so if we're graphing this x is less than 5, I'm putting the number line down. And I'm going to put my 5 right in the middle. So I'll put some numbers on the other side, 4, 3, and 2. And 6, 7, and 8. You need a number line. Because you want to show that there's lots of numbers. And a great way to show all the numbers is with a number line. Okay? Then, after you have your number line, you are going to use either an open circle or a closed circle. You have to ask yourself, open circle or closed circle? Which one will you use here? Well, we talked about this a little bit at the very beginning of the year. An open circle, something that looks like this, is used when we have less than or greater than. Strictly less than, never equal to, or strictly greater than, never equal to. Okay? In this case up here, we are strictly less than 5. So I'm going to put an open circle down at negative 5. Excuse me, at 5. Closed circles, we're not going to use one here, but closed circles are used when we have that equal to part. Okay? Picture it this way. Picture it like a giant hula hoop. You put your hula hoop at that number. When you can be equal to, you can stand in your hula hoop. And then what happens then is you shade in. You kind of picture a little person standing there doing a dance or something. Shade it in. Show that you can be equal. Show that you can stand at that number. If you can't, your numbers get all the way up to it, but they never actually go all the way in. And that's why your hula hoop stays open. Okay? Open circle, closed circle. Make sure you do the right one. You finish, shade. Shade your number line to show which numbers are part of the solution. To show which numbers work and which numbers don't work. Okay, in our case, we are talking about numbers x is less than 5. So we could test a couple numbers, although I think we already know which ones we want and which ones we don't. But if we test those 3, 4, 5, and 6, is 4 less than 5? Yep, you bet, Miss Visto, it is. Great, I know that that part is in my solution set. Is 5 less than 5? No. Well, we already said that. That was the point of the open circle. Is 6 less than 5? No. We don't want 6. Okay? All we want here is we want that 4. So we're going to shade the part of the number line that goes through 4. And of course, 0 is less than 5. Negative 5 is less than 5. So we're going to make sure that arrow goes forever. That's how we're going to use the graphing part and representing it graphically. So when it says graph, whenever you have an inequality, you need to graph the solution set. Okay? Speaking of that, I have 4 problems for you to try. 4 problems. Here they are. Give them your best shot. Oh, no, just kidding. We're missing one. Give them your best shot. Make it happen. Try these, please. Push pause. Ready, go. Okay, now check your work. How did you do? Okay. In that first one, lots of different steps there, but you should have gotten W equals 6.3 repeating, or 6 1/3. The second one, ooh, you got an identity, 6 equals 6. Okay. Careful with the distributive property. Careful with collecting like terms. As soon as you see this line right here, 6 minus 9x, and negative 9x plus 6, you kind of can see that you have the same thing on both sides. Okay? Because 6 minus 9x is the same as negative 9x plus 6, but we added to both sides, and we figured out, oh yeah, 6 equals 6. That tells us that our answer is all real numbers. Any real number works there. And number 3, pretty easy solving. Okay? End up with x is greater than 4, and so we put an open circle and shaded to the right. And this last one, when you solved, you ended up right here. Your brain maybe needed to pause and think about that, and you want to maybe visualize it as x is less than or equal to negative 12. Okay? All we're doing is we're just kind of reading it in terms of x because that makes it a little bit easier to graph. Okay? So some things we talked about. We talked about how we solve. We have that block method process. And then we talked about different solution sets, identity, contradiction, and of course our graph. So when you're thinking about this lesson, keep those things in mind. Block method, and then the different solution sets.